Hi, everybody. So today I wanted to go ahead and do a little review from the beginning of our unit on samples and surveys. We made it pretty clear that we were going to do review from sixth grade again. So any of you who've now joined us from a different school and you're in sixth grade, maybe you'll enjoy this. Samples and surveys. Remember, we talked about a population and how you had to choose your population carefully. You could not say eighth graders. That would mean eighth graders of the entire world. You have to be more specific. Eighth graders in Chicago. Okay, well, Chicago's a really big city. So then we decided to just do eighth graders in our district. I don't want to use names of our school, so we'll leave it at that. We then said, okay, now I need a sample size. So my population is all eighth graders in our school district. But I need a sample. I can't talk to every eighth grader in our district. So I had to choose only eighth graders in our school. And how many is that? What is the sample size of that? In our case, it would be 120, but in this case, we just have one classroom, and I wrote down 25 people. Be careful about that population. That is the biggest problem here, is that students choose a population that is too large to have a real survey for. So be careful. I suggest a population is eighth graders at your school. Then your sample is just one classroom of eighth grade. That would be 25 people. Two types of samples, random or biased. We talked at great length that a random sample is very rare. That would mean that every single person in the population has an equal chance. Random samples just don't exist very often. All of the sampling and all of the data that you see on TV, those are not random samples. They are asking such a small portion of a population that questions. It is not random. They are biased. And although we talked about the word bias having a negative connotation, as you learned in language arts, it doesn't mean negative in the world of math. It's absolutely the most common. It is not as reliable. Everyone in the population did not have the same chance to be in the sample, but it is absolutely realistic. You can have a biased sample and you can have good data that is worthy of documenting. Remember vocabulary? We went over this. Random, by chance. Everybody has a fair and equal chance. Systematic, according to a rule. So you can say boy, girl, every third person, whatever you want, short, tall. It doesn't matter. Whatever your system is going to be, you can have systematic sampling. Stratified is the hardest one to remember. Stratified means you have a random from a random group. So it's layers of random. I take your school, and you can't talk to everyone in your school. No, let's go back. Let's take the district, and you put every school's name in a hat, and you pull one out. Everybody had a chance. You pulled one out at random, and you go to that school. Now you get to the school, and you realize they have 150 eighth graders, too many for you to talk to. So you now put everybody's room number in a hat and randomly pick a room number out. Now you've narrowed it down to 30 children, and you can realistically go and speak to 30 children. So you did layers of random. That's called stratified. Convenience. I'm at home. I forgot to do my homework. I'm just going to call some people because I'm just going to call my friends. I'm going to ask my family, whatever was convenient for me, the easiest to reach. Voluntary. People who choose to participate, set up a table in the hallway and see who stops by. Anyone who stops by does so voluntarily, and you talk to them and you get their sample. So how are we going to organize this data once you have it? We talked about a line plot. Line plots are like frequency tables sideways. All of a sudden, I'm horizontal instead of vertical. I list all of my possible outcomes on the data line, and then I just put these X's every time that data point recurs over and over. I'm going rather quickly because we've already discussed all of this in class, but feel free to stop the video if you want to. This is used really well for finding the mode. Mode is most often. We will get to mean, median, and mode in another video, but right now mode is good with line plots. Oh, the dreaded stem and leaf plot. We do recall the dreaded stem and leaf plot. We tried for a long time to figure out what we were going to do with this and how we were going to use it. Remember, the stem is all of the digits except the last one, which we call leaf. They both begin with L. It's a little helpful. The leaf is also the last thing on the tree. You have the trunk, the stems, the branches. Leaf is the last thing that comes off the tree. Here are my examples. 34, I have a stem and a leaf. 365, this is one that usually people get confused. They're not sure if the 36 is the stem or the leaf. I'm telling you now, it's the stem. 6, there is no stem. That means the stem is 0. We use 0 as a stem when there's nothing there. Here's my data set. I can look at my data set, and anywhere there's no stem, I automatically recorded it in the 0 row. The leaf is 2, the leaf is 5. 13, 1, 3, 1, 3. 1, 7 is 17. 1 and 8, 18. 20, 22, 26, 31, 37. You should be able to look at a data set, create a stem and leaf, and look at a stem and leaf and create the data set. Again, you can locate mode by looking at repeated leaves. I see 2 3s here on the same row. That will be my mode. It has a stem of 1. Those are 13s. You can also have a back-to-back stem and leaf. In this case, I have the age that you learn to tie your shoes. I have girls in red. I see that they learn to tie their shoes at 6, 7, and 7, 12, 13, 14, and 21. Clearly, this is not correct data. This was just for us for fun in class. Boys, let's see, you learned to tie your shoes at 11, 12, 15, 24, 25, 27, 32. Okay, clearly it was fictitious data. But it shows you that your stem always goes down the center. You can have 2 sets of leaves. They must be in numerical order, starting at the stem. The stem is also in numerical order from top to bottom. Normally, you will have to write a stem and leaf more than one time because the first time you just record the data. The second time, you rewrite it in numeric order. Notice that we start at the center, just like a number line. How you have 0 in the middle of a number line. Your positives go to the right, your negatives go to the left, and the actual digits get larger as they move away from 0. A Venn diagram. You did lots of these in language arts, but here it is in math. You can record 3 sets or more of data. Here I did gender and age, record children over or under the age of 12. If you are under 12, you automatically go in this center. You do not get counted in the red. You do not get counted in the blue because you've already been counted here in the center, and you can only be counted one time. You have many examples in your notes that you have already where we looked at how to make a Venn diagram, where to put the data, but just be aware that you cannot duplicate the same people, okay? Let's take a look at how do you know what the best graph is that you should choose now that you've made all these graphs? A bar graph. Data at one point in time. It compares the frequency at one point in time. Remember frequency? Those are your little tally marks. A line graph. Line graphs are used for data over time, not at one point in time. Histogram. Intervals of data. You still have frequency, but it's divided into intervals. Remember, those are the bars that never touch. You may have already watched that video. Stem and leaf. Data distribution. You might be looking for medians, but we also just said that you could use that for modes. Oh, the box and whiskers. Box and whiskers. Also, data distribution. You are definitely here looking for medians, the middle values. Remember, in a box and whiskers, you have 4 sections, and every section is equal, even if they don't look equal. Line plot. Don't get that confused with a line graph. A graph is a line going up and down in a coordinate grid. A line plot is just a frequency table using x's. Scatter plot. Here you will have 2 sets of data. Lines of best fit. I'm actually going to do a slide on that. A video is coming on scatter plots. So 2 sets of data. They can be related or they don't have to be related. We will be looking for lines of best fit and correlation when you get to scatter plots. Circle graph. Here you have parts of a whole. You must have 100%. Be careful if you do not have 100%. You cannot have a real circle graph. One last slide that I'm going to add in here. Misleading graphs. When kids make graphs, how do you know they work? You have to be careful. Your scales, they must start at 0. They can't skip. You have to start at 0. Your intervals have to be equal. You can't go 0, 5, 20. If you're going by 5s, the whole graph has to be by 5s. They have to be equal. You can have circle graphs, but remember that they have to add to 100%. Circles must be 100% or it can't happen. Samples that are not random. In a random sample, all members of the population have an equal chance of being selected. Random samples are rare. Symbols and keys must be even. You can't have one symbol 3 times as large as another symbol, and then people will automatically think, well, if the symbol is larger, well, that must mean it's worth more. You can't do that. The size of the bars have to be equal, and the shapes have to be equal. And histograms must have equal intervals. I hope you enjoyed. A little shout out to Alexander for my little SpongeBob. He's going to be helping me with several of my videos in the future, and I'll be back with more videos.